Hello guys, welcome to the new video. In this video, we are again going to do an interesting proof which is related to prime numbers. And the statement goes as follows. Let p be some prime number, and if p divides a square where a belongs to some natural number, then p divides a. This is the statement and we have to prove it. Think for a while about the very formal proof for the statement. Now, let's try together. So, if p divides a square, then p divides a, the statement that we need to prove. Now, let's write a as product of some prime numbers p1 into p2 into p3 up to so on pn, right? And this may not be distinct, right? Suppose we have 2 square into 3 square. What I'm saying is write it as 2 into 2 into 3 into 3. Just split it, right? And every power of prime number is 1 and they're all not distinct. See, p1 and p2 can be same like 2 and 2. p3 and p4 can be same like 3 into 3. So what I'm saying is just factorize a into p1 into p2 into p3 into up to so on pn, where there can be repetitions. p1 and p2 might be same because it's actually p1 square. We are writing it as p1 into p2. So p1 p2 can be same. p2 and p3 can be similar. So we are factorizing such that the power of every prime number that is going to be there is 1, and p1 can be equal to p2, p2 can be equal to p3 because power can be anything, right? So we are factorizing to the power 1. So we can do that without loss of generality, right? Now, if this is the a, what is the a square? It is simply going to be p1 square into p2 square into p3 square dot 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 pn square. This is our initial setup. And let's read the statement. If p divides a square, then p divides a. So let's assume that p is dividing a square. What does that imply? If this is true, can you tell something? Can you tell any other statement? If this is true, can you tell any other statement that is also true? If p is dividing a square and these are all the primes that are there, then p must be p1 or p2 or p3 or pn, right? If p is dividing a square, we can reduce the space, search space for p. Initially, p can be any real number, any natural number. Initially, p can be any real number or any complex number or anything. P can be anything. But when you know that p divides a square, we can reduce the space, possibility space for the p, which brings p to either p1 or p2 or p3 or pn. P should be one of these following n numbers. Because if, let's assume, if p is not any of these numbers, it's not p1, it's not p2, it's not p3, it's not pn, it's something else which is not this present in these n numbers, then the statement p divides a square is not possible, because p is a prime number and it is dividing a square. Then we should see that p in the prime factorization of the a square. But if you are not seeing p in the prime factorization of a square, it means that p cannot divide a square. But we know that P is dividing A square, which means P should be one of P1 or P2 or P3 or Pn, because P should be present in the prime factorization of the A square. So if P is one of these following, then this implies P divides A, because let's assume that P is P1. So, and we know that A is P1 into P2 into P3 into and up to so on Pn. So if P is P1, then P1 divides A is true. If P is P2, P2 can also divide A1. If P is P3, P3 can also divide A. If P is Pn, that then also P can divide A. So if the possibility space for P is P1 or P2 or P3 or Pn, then for sure, for this range of P, for this possibility space of V, for every value present in this range of P, the statement P divides A can be generalized, and P divides A must be true for any value of P that is there from P1 to Pn. So, logically, if P divides A square, then P must divide A. I hope this statement is now comfortable for you, and we have proved it successfully using prime factorization. If P divides A square where A is belonging to natural numbers, then P divides A is true, and it must be true. I hope you really enjoyed this video. If you really like this video, please like, share and subscribe. Thanks for watching.